So we're going to go over the first 6 problems on the problems that I put on the web page, step by step, so you can see how it's done. And here's the first one. So the first thing we're going to want to do, we're asked to find this side x, given an angle theta and given another side of this triangle. So the first thing we're going to do is identify relative to theta, which is the 62. Remember, that's our theta. I'm given theta in this case. Where is opposite, hypotenuse, and adjacent? Well, the hypotenuse is going to be this side opposite the 90-degree angle. If I start over here and I go to the opposite side of the triangle, this would be the hypotenuse. I'm not asked to find it. I'm not told what it is. I don't care. So I'm not going to use any function that has hypotenuse in it. X relative to theta, relative to the 62, x makes up this angle theta along with the hypotenuse. That makes it my adjacent side. And this 23, if I start at this vertex where this angle theta is and I go across, 23 would be opposite. So if I think of my trig functions, if I look at them, I want a function that has opposite and adjacent, and I already know what theta is. I'm asked to find adjacent, and I'm given opposite. So the only function that can help me do that is the tangent function. So let's take a look at this. I know that the tangent of theta is opposite over adjacent. I want to find adjacent. This is my unknown. So I have to isolate that. And remember, when we isolate something that's in the denominator of a fraction, the first thing is to get it out of the denominator. I'm going to multiply both sides by a. This is the same as multiplying it by a over 1. So you can see here I end up with a over a, which is 1. 1 times the opposite side is just the opposite side. I'm going to multiply this by 1. Or I'm sorry, I'm going to multiply this by a. So I get the opposite side is going to be the adjacent side times the tangent of theta. My x is the adjacent side. I want to get a by itself, so I'm going to have to divide out tangent theta. And I'm calling a, tangent theta over tangent theta is 1. I'm calling a x, so the adjacent side, the unknown, I'm calling it x. So it's going to be the opposite side, which I know is 23, divided by the tangent of theta, and I'm told theta is 62. When I punch that into my calculator, 23 divided by the tangent of 62, I get 12. So the answer to that is 12. If you didn't get 12, check and make sure that you're in degrees and not radians. And again, a quick way to do that is take the tangent of 45, and if you're in degrees, which you should be, it should equal 1. It will equal 1. All right, let's do the next problem. I am asked to find this side of a right triangle given some angle theta. So my theta, I'm told, is 23 and told that this side is 19. First step, what's opposite, adjacent, and hypotenuse? That's going to help me pick the correct trig function. So first, let's find the hypotenuse. I'll start with that 90-degree angle. My unknown in this case is my hypotenuse. So I need one of these functions with hypotenuse in it. So either sine or cosine, I can see over here. 19, is this opposite theta or is it adjacent? Well, the 19 makes up the angle theta along with the hypotenuse. It makes up theta, so this is the adjacent side. This side here is opposite, but who cares? I'm not asked to find it, and I don't know what it is. So what function has adjacent and hypotenuse in it? The cosine function. So I can go over here, and I can see that that's cosine, so let me write out that function. I know the cosine of an angle is adjacent over hypotenuse. I'm asked to solve for hypotenuse. That's in the denominator of this fraction, so I've got to first move it to the numerator. So h over h is 1, so I can get rid of that, and I end up with the adjacent side equals hypotenuse cosine theta. I want to solve for hypotenuse, so I divide both sides by cosine theta. Remember, cosine theta is stuck together. I can't treat these as separate things. They're stuck together. So I end up with hypotenuse, which I am calling x, equals the adjacent side, which is 19, divided by the cosine of theta, and I'm told that theta is 23. When I solve for x, I get 21, and I put that in my calculator. I get 21. Let's do this last problem. Oh, look at this. So this last problem is deceptively easy. There's no angle given to me at all. It's just a Pythagorean theorem problem. So I'm told that the hypotenuse of this right triangle is 54. And remember, actually I'll call that c. Remember, in the Pythagorean theorem, a squared plus b squared equals c squared. and C has to be the hypotenuse. So I'm given the hypotenuse and a leg of a right triangle and asked to find the other leg. We've done this before. I can call this unknown letter A in terms of how I'm using this Pythagorean theorem, just so you can see what we're doing here. First thing I'm going to do is get it by itself. So I'm going to subtract b squared from both sides. I end up with a squared. B squared minus b squared is 0. So I end up with a squared plus 0, but I don't have to write that plus 0. Equals c squared minus b squared. I'm going to take the square root of both sides. I don't want to know what a squared is. I want to know what a is. The square root of a squared is a. Whatever I do to this side, I have to do to the other side. So that's going to be equals c squared minus b squared. C is 54. So 54 squared minus 41 squared. And when I put that in my calculator, and I'm calling this unknown x, so I'm going to write this as x. When I put it in my calculator, I get 35. So those are the first 3 problems. If you got them wrong, figure out where you went wrong. Don't just keep moving on. Figure out what mistake you made. And now let's work on the second 3 problems. Okay, here are the second problems. I'm asked to find an angle and I'm asked to find an unknown side. So you could do whatever you want. In terms of finding this angle, we're going to have to use trigonometry. We can also, once we know the angle, use that to find that side, but that seems kind of silly. We can use the Pythagorean theorem to find x. So first let's find x. And when you hand in your homework, it is helpful if you put in just a short little heading like this so I know what calculations you're doing. It shouldn't be a scavenger hunt. So this is my hypotenuse, 11. It's that side opposite the right angle, opposite that 90-degree angle. This is my hypotenuse. So that's going to be C when I use the Pythagorean theorem. So I have a squared plus b squared equals c squared. It is the leg that I'm solving for. This x is one of these legs. I can call it A or B. I'm not going to write out all the steps. Hopefully you're seeing what those are. So it's c squared minus b squared, the square root. And now let me just substitute. I'm calling that x. My unknown side I'm calling x. And I have 11 squared minus 3.5 squared. Take the square root of that, and when I do, I get 10.4. So I'm going to put a circle around that and see how you can follow the work, and it's one thing after another, and it just goes all down in a row like that. Very easy to follow. So try to do that when you give me your answers. And now let's try to find theta. You have a hypotenuse. You're told that that's 11, and what is this side 3.5? Is this adjacent relative to theta? Is this adjacent or is this opposite? Well, it's adjacent, right? Because along with the hypotenuse, this makes up the angle theta. This is adjacent. Now, you might say, hey, I just found out that x is 10.4, so I can use that. I can use whatever function I want. I know all 3 sides of the triangle, and that's true, and you could. But wherever possible, avoid using some calculated value in a new calculation. You're given 11, you're given 3.5. We know those are right. We know we didn't round them or do anything to them. So whenever possible, try to use those. It's not wrong to use your this calculated value here, but it's preferable not to. If you made a mistake, you would just end up carrying a mistake along with you into another part of the problem. And why do that? So what function out of my trig functions here, I have SOHCAHTOA, so let's go write this out. What function am I going to use that has adjacent and hypotenuse? And the answer is I'm going to use cosine. The cosine function has adjacent and hypotenuse in it. So let me write that out. I know the cosine of theta is adjacent over hypotenuse, and I'm trying to solve for theta here. So I have to get theta by itself. Remember, I can't just divide out cosine. That's not how it works. In order to undo taking a cosine, I take the inverse of that function, the inverse cosine. So I'm going to take the inverse cosine of both sides. The inverse cosine of cosine is theta equals the inverse cosine of adjacent over hypotenuse. So now that we've isolated it, we can just plug some numbers in. What does theta equal? It equals the inverse cosine of the adjacent side is 3.5, and the hypotenuse is 11. And when I put that in my calculator, I get 71 degrees. So that is what that angle would equal in this case. Now I'm just going to delete this here because it's kind of taking up the whole page, and we'll do the next one. And this problem here, I'm given 2 sides of a triangle and asked to find theta. So I need to find out, well, what are these 2 sides? Let me get a color here. So here's my theta, and this would be opposite. Well, I'm not told what opposite is, and I'm not asked to find it, so who cares? This is across from the 90-degree angle. There's 33, so this would be the hypotenuse, and 12 along with the hypotenuse makes up this angle theta, so that would be the adjacent. So what function has adjacent and hypotenuse in it? Once again, it's cosine. So I'm going to use the cosine function. So I know the cosine of theta is adjacent over hypotenuse. Theta is going to be the inverse cosine of adjacent over hypotenuse, and now I'm just going to substitute. The adjacent side is 12, the hypotenuse is 33, and when you put that in your calculator, hopefully you get 69 degrees. Okay, if you're not getting this, just check. Remember your calculator, when you hit that cosine button, you should hit shift and then cosine, which on your display should bring up the inverse cosine. And it should open parentheses for you. If it doesn't, open your own parentheses. 12 divided by 33 is just a division problem. Close your parentheses, hit equals, and you should get 69. If you're in degrees, that should be the answer you get. If you're in radians, get out of radians and get into degrees. And finally, this one, you're given an angle theta, so that 57 is my theta, and it's known. You're given a hypotenuse. You should recognize that this number 12 is the hypotenuse, and x is adjacent to theta, and so you should recognize that. What has adjacent and hypotenuse in it? Look, it's cosine again, so we're going to use the cosine function again. Cosine of theta is adjacent over hypotenuse. I want to solve for adjacent. This is my unknown. I want to get it all by itself on one side of the equal sign. So how do I get rid of dividing by a hypotenuse? I multiply by the hypotenuse. So if I multiply both sides by the hypotenuse, I'll put it over 1 so you don't get confused. Not that you would get confused by this, but you never know. So adjacent is h cosine theta. Now I just substitute. I'm calling it x. And the hypotenuse is 12, and theta is 57. And so when you put that in your calculator, you will get 6.5. Put a circle around it. And that is how you solve these problems. And there's plenty more practice problems if you need them.